What you're about to see is a hardware validation story structured in 3 parts: failure, engineered solution, production proof. We're starting with failure because understanding what goes wrong is the only honest way to demonstrate what going right actually means. Our first dataset comes from early stage R&D on an A100-based immersion server at Denver DataWorks. This represents a worst-case scenario benchmark for a system with suboptimal heat sink design and improper thermal management. We're showing you this data intentionally, not to highlight a product, but to establish a baseline for what insufficient immersion implementation may look like in the real world. We used HPL, High Performance LINPACK, to stress the system. Sustained GPU utilization, maximum thermal load. And here's what we observed. Thermal slowdown counters climbing over time. Heterogeneous performance across GPUs. Some accelerators degrading faster than others. Inconsistent power draw. And clock rates dropping by 50% under thermal stress. This is textbook thermal throttling. The GPUs exceeded their thermal limits. Firmware stepped in to protect the hardware, and compute throughput paid the price. The uneven behavior across GPUs tells us something else. Uneven thermal distribution, localized hotspots, poor coupling between components and the fluid. The takeaway here is simple but critical. Immersion servers not fit for use may have poor performance. System-level design can overcome it. Now we move to the H200 platform. Same HPL methodology, direct comparability, but a fundamentally different system. This fully immersion native design, co-developed and validated at both hardware and the system level. Purpose-built heatsink geometry, updated power architecture, full system-level validation from the ground up. And here's where it gets interesting, because this is a more significantly demanding platform. We're talking 700 watts GPU TDP. Compare that to 400 watts of the A100. And by the way, we shrank the form factor of the H200 chassis from 6U to 3OU in order to double the server's GPU density. More power, more heat, higher stakes. And the result? No detected thermal slowdown events. Stable, consistent power draw across every accelerator. Homogeneous performance across all GPUs. No overheating, no thermal instability. None. The absence of throttling tells us that the thermal capacity of this system exceeds its load, even at 700 watts. The GPUs ran continuously at full performance. No hidden degradation, no intermittent drops. This is a direct answer to a concern that has followed immersion cooling for years, that it won't scale to higher TDP GPUs without performance trade-offs. It scales. The data shows it. But synthetic benchmarks only tell one part of the story. The final test moves us out of the lab and into a real production AI workload. Continuously batched inferencing using Llama 3.1 Instruct 70 billion parameters. High concurrency, sustained utilization. This is a NeoCloud use case. This is what the system actually needs to do. Real AI workloads behave differently from benchmarks. Dynamic utilization patterns. Memory and compute interacting continuously. Requests arriving without pause. So what do we see? Stable, repeatable GPU power profiles. No thermal throttling. Consistent performance across all GPUs. No progressive degradation over time. Predictable behavior under sustained load. The power cycling you observe and the data reflects expected batching and processing behavior, not thermal instability. That distinction matters. This is not a lab result. This is production AI workload performance with no thermal or performance degradation. So let's bring this together. 3 tests, 3 answers. The A100 baseline showed us what thermal events look like when immersion is deployed without proper system-level engineering. The H200 HPL results showed us what happens when you solve that problem. No throttling, even at 700 watts. And the Llama inferencing results confirmed it holds under real-world conditions, stable, reliable, and consistent. When immersion cooling is implemented as a truly immersion-native system, thermal limits stop being the bottleneck. No throttling at 700 watt TDP. Proven reliability with multi-year in-tank operation. Up to 14 servers per rack. No observed thermal sealing under current platform conditions. Immersion isn't just viable at scale. It removes primary constraints limiting AI infrastructure today.